Well, hello, friends. How are we all today? So we are going to continue on through this idea of exponents and logs. And today we're going to go through the next step. And that next part is solving exponential equations and logarithmic equations. Now, we've done some of this, right? But we're going to go a little bit further and just talk about a few more types of things we could do. So these first couple, we've actually already gone ahead and solved them. So why don't you guys take a second, pause the video, try number 1 and 2, just make sure we're all on the same page. All right, let's see how you did. So first of all, the 27x to the 9. So this 3.4, we're actually breaking up into 2 videos just because there's a lot here. All right, so 27 is the same thing as 3 to the cube. So friends, if you want to break it up too, definitely don't mind you. I mean, I'm not gonna lie. You hear me talk, I can talk forever. I can probably put you to sleep. So good news is we found a cure for insomnia. It's me. All right, so we got exponent raised with an exponent. That's 3 to the x, 3 to the 3x, 3 squared. Once the bases are the same, then we set them equal to each other and we solve. So 3x equals 2. Which means that x then is 2/3. So it's not too bad. When we did these we did them a couple days ago. So this is just a little bit of a review to make sure that we're all on the same page here. We've been doing, I guess, the last couple of days because we can turn our log expressions into problems like this. Apparently, those of you guys that are in third period right now, it's done. So you're going on lunch. Just don't come here. We're in the middle of a video. All righty. So now we're trying to get it by itself here. 2 to the negative x plus 1 equals 16. And I believe I can get those to be the same base. So 16 could be 2 to the 4th. So some exponential equations we've been dealing with for a while. You actually started solving these back in integrated 1. So it's been a few years. You hopefully are feeling pretty confident about a lot of this stuff. So negative x plus 1 equals 4. So we go ahead and we finish all this out. We get negative x equals 3. And that means x equals a negative 3. So that's just a little start. Now we're going to start to use some of our log rules and to see if we can't go through and maybe just try and solve just a little bit more difficult type of problem here. Let me show you what kind of I'm talking about. So let's take a look at 3 and 4. If you want to go ahead and pause the video, actually take a look at 3, 4, and 5. Give it a shot, pause the video, and then we'll come back and talk about it. All right, so let's try these here. So first up, number 3, I got 3x plus 2. Bunch of ways I could look at this. Bunch of ways I could look at this in general, but I'm going to notice that I have an exponent hanging out in my problem here. And I've learned that anytime I have an exponent on a log, I can move it out in front and make it multiplication. So 3x plus 2 equals x minus 2 times the natural log of e. Now we've been dealing with this for a couple of days now, so I'm hoping we're feeling pretty good about this, because in that we realize that the natural log of e is the same thing as log base e of e, and if the base and the number you're taking a log of are the same, we've said that that equals 1. So if we come back to that idea, we have 3x plus 2 equals x minus 2 times 1. So, or just x minus 2. And from there, it's a pretty straightforward little problem for us to solve. We're just going to go ahead and do a little bit of algebra. Whoop. So subtract x from both sides, I get 2x. Subtract 2 from both sides, I get a negative 4. So that means that x then is equal to negative 2. So just using our rules of logs to kind of help us clean things up a little bit. So let's see here on this next one. I could use logs again, but this looks like just a pure exponential equation. So I'm kind of curious to see if you guys treated it like an exponential equation or not. So I see an 81 and I see a 16. On the other side, I see 2 and I see 3. Now notice how I put that in parentheses because we're going to be playing with that here in a second. Is there a way I can get 81 in terms of 3 or 2? Is there a way I can get 16 in terms of 3 or 2? Well, 81 is 9 squared. And that means 9 squared is 3 squared. So 3 squared times 3 squared would be 3 to the 4th. I think 81 is 3 to the 4th. And 16 is 2 to the 4th. The cool thing is they both have that 4 as an exponent, so I can go ahead and, in a way, I mean, it's not really factoring, but I can rewrite it, and it's going to kind of look like factoring. I can rewrite it in such a way that I can use just one exponent. So I'm going to bring that 4 to the outside, like that. And if I wanted to get rid of it, make these bases match now, I need to take that 3/2 and I need to flip it. So in order to flip it, I have to introduce a negative exponent. So we can make this 2/3 to the -4. So that means now that the bases are the same, that means the exponents also have to be the same. So x equals -4. In this last one here, natural log of x minus natural log of 2. So I could look at this in terms, there's a couple ways I could solve this. I'm going to solve it what I think is the easiest way. If I move one natural log to the other side, I get natural log of x equals the natural log of 2. And then just like with exponents, when they have the same base, you can get rid of them. It's the same thing with logs. As long as you have the same log on both sides, I can get rid of it. So x equals 2. So that's one way to solve it. For my purists out there, if you want to use a little bit more of some sort of a log rule, if you remember that when you're subtracting logs that have the same base, you can combine them with exponents. Or I'm sorry, combine it with exponents. Combine it with division. So x minus 2 would be the same thing as x over 2. So natural log is the same thing as log of base e. Again, this is just another way to solve it. It's not the way I would recommend, but it does work for you. So I'll just separate that and make sure we can see that these are two different ways. So stuck in log form, go to exponent form. So e to the 0 equals x over 2. So e to the 0 is 1. And to get rid of the x divided by 2, I multiply 2 by both sides, and I'd get 2 equals x. So do two different ways to kind of look at the same problem there. Again, obviously, I would probably have chosen the purple because, well, it's quicker. But it all depends on whatever you see. Neither one is wrong. It's whatever you see. All right. We'll keep going here a little bit. Let's try just a couple more log problems. So why don't you guys pause the video on 6 and 7 and see what you guys can do with it. All right, here we go. So this time I have a variable for my base. So 25, log of base x of 25 is 2. So I'm stuck in log form. I can go to exponential. So the base is always the base and the numbers switch sides. All right, so now we're just going to take a square root here. So I'm going to square root both sides. Whoop, whoop. There we go. So that means x is plus or minus 5. But now remember what we've been saying the last couple of days. A base can never be 0 and a base can never be a negative number. So that being said, x can't be equal to -5. It's just going to be a positive 5. So -5 would have been an extraneous solution. Can't have those. All right, let's try this next one here. Natural log of 2x minus 1 equals 5. So I'm going to go ahead and change natural log to log base e. And again, if you're doing that in your head and you skip this step, totally good, totally get it. No harm, no foul there. That was almost an e. Yeah, that's kind of an e. 2x minus 1 equals 5. It's a lot of fun to try to write with the mouse on the computer. So now the e is going to stay the base since that's the base of the log. So e to the 5th equals 2x minus 1. Now it's just a matter of just solving for x, get x by itself. I'm not going to plug it into my calculator. I'm just going to leave e in terms of e, just like we did with pi. Just leave it alone. So e to the 5th plus 1 equals 2x. And then I'm divide both sides by 2, which is the same thing as multiplying by 1/2. And I find out that e to the 5th plus 1 equals x. All right, so we got a few more we're going to go through here. And then, like I said, we're only going to go halfway through this, and then we'll create a second video for the harder ones, the longer ones after this. But we'll go and finish this up here. We'll go a little bit further. All right. So let's take a look at 4, or just at 8. So if you want to pause the video, you can, but we're just going to go and just jump right on into it here. All right, so I see 4 e to the 2x equals 40. Divide both sides by 4, I get e to the 2x equals 10. So I'm stuck in log form. Now I got a couple different ways I could go about doing this. All right, so I'll write it twice here. First way I could do this is I could make, since I'm stuck in exponent form, I can go to log form. So I can make that base be the base of my log. So log base e of 10 equals 2x. So this is a totally fine way to do it. And if I were to do it that way, again, log base e is the same thing as just natural log. So I could change that to natural log of 10 equals 2x. And then to get the x by itself, I could take 1/2 or divide both sides by 2, which is the same thing as multiplying the other side by 1/2. So that's one way I could do it. The other way I could do it is if I were to take a look at the problem and I do the same log to both sides. So for instance, if I wanted to, I could do log on both sides. So log e to the 2x equals log base 10. So if I move that 2 to the x out in front, I get 2x times log base e, or log of e, I'm sorry, not log base e, equals log base 10. And by the way, log base 10 of 10 would have been 1. When their logs are the same thing, that equals 1. What you're going to see, there's a lot of different ways we can come up with answers. There are different answers, but they all work. So if I divide both sides by log e, I get 2x equals 1 log e. And if I multiply both sides by, or multiply both sides by 1/2, I get x equals 1/2 times 1 over log of e. So that's another way to do it. One other final way to do it is, again, I could do any log at once. So what if I just did natural log on both sides? Nobody ever said I had to do just a straight log. So log base e of 2x equals the natural log of 10. So the 2x would go in front, and this is going to start to look very similar to the very first answer we have. And so natural log of e, that would be 1. So natural log of 10. And then, so 2x equals natural log of 10. So x is 1/2 natural log of 10. Again, same exact answer as we had in the very first one. Cool thing is a bunch of different ways to do it. You just got to take your pick and figure out which way you like best and go for it. All right, well, friends, why don't you do me a favor? Why don't you guys go ahead and pause the video and see if you can try using this idea, one of these ideas, try number 9, see what you come up with. All right, well, let's see how you did. I'm going to go ahead and log both sides. So one way would have been to go ahead and log both sides. So I get log base 8, or not base, log of 8, negative 2 minus x equals log of 431. Exponent goes in front. Equals log of 431. So when I divide both sides by log 8, I get negative 2 minus x equals log 431 divided by log of 8. And then add 2 to both sides. Whoop. So we get log 431 over log 8 plus 2, and then divide by negative 1. So x equals negative. So this is one way you could have done it. And again, whether you choose to go one way or the other doesn't matter. It's really preference. It's really preference. So the other way we could have done it would have been going over here and saying I'm stuck in exponential form, so I'm going to go to log form. And if that's the case, then the base of my exponent would still be the base of my log. So I could have gone log 8, base 8 of 431 equals negative 2 minus x. So we have 2 plus log base 841, 431 equals negative x, and then divide both sides by negative 1. And again, friends, it's whatever makes the most sense to you. I don't care what you do. So as long as it makes sense to you, go for it. All right, let's try a little harder one. Go ahead and pause the video and see what you can do with number 10. All right, so this one is just a little bit tougher because I got exponents on both sides. And again, there's multiple ways to do this one, but I'm just going to do it in one way. So I'm going to start off, I'm going to log both sides. If I chose to go log base 6 on both sides, I could also clean up one. If I go log base 5 on both sides, I clean up the other side. Otherwise, I can just log both sides, which is always okay. That's just the way I chose to do this one. Again, it's not wrong to go one of the other ways. 3x plus 1. So I bring those bases out in front. Equals x minus 7 log base 5. And then I'm going to distribute my log integral. So I have 3x plus 1, 3x log 6, sorry. So I'm going to multiply my log 6 into both sides. So multiply both these by it. Likewise, I'm going to do the same thing with the log 5. I'll multiply both sides by these by it. And again, multiple ways to solve these. This is just one. So you can get answers that look different than mine and actually have a decent looking answer. X log 5. So now I got x's on both sides. So I'm going to go ahead and get my x's to be on the same side. So since I have my log base 5 here, I'm going to move my log base x log 5 to the other side here. So if I move them over on this side, and just to make sure we're clear on what sides are which here, I don't want to get confusing here. And then I'm going to go ahead and subtract the log 6 from both sides. I end up with 3x log 6 minus x log 5 equals -7 log 5 minus log 6. So I still have 2 x's and I really only want to have 1 x. So because of that, I'm going to go back in, divide out that x. So if I were to divide out that x, I would end up with 1x. So if I factor it out, I got 7 log 6. And I got a negative log 5. So by factoring, and I'm going to bring this up over here, I now have x times 3 log 6 minus log 5. That would be equal to -7 log 5 minus log 6. Okay. So that says 3 times that whole thing. So now I can go ahead and divide out this log here, this ugly log, and I can get x by itself. And again, there's a bunch of different forms to write this final answer. This is just one form. It all depended on the choices you made earlier. And I kind of like that. I kind of like that it's all based on choices you make, right? We all think differently. And that's kind of a beautiful thing. If we all thought the same, that would be an extremely boring world, but we all think a little bit differently. So you get to instill a little bit of your personality into how you solve these, which is, I'll be honest, friends, that's so cool. All right, minus log 6. And the whole thing over 3 log 6 minus log 5. And that would be a fantastic answer. It's an ugly answer, but it's fantastic. If you want to plug in your calculator as well, you could, and you get yourself a value that'd be a decimal value. But there you go. All right, friends. Well, why don't you guys go and pause the video, try number 11, and then we will get ourselves, we'll see how you did on it. Okay, go for it. All right, our second to last problem here. Second to last problem. All right, let's see here. Well, this just kind of looks gross, right? So we're going to go ahead and do a little bit of arithmetic here, just a tad bit. We're going through problem 12 here on this first half, and we're going to hit pause. maybe if you be a great time to go ahead and try to see if you can solve some stuff. So anyways, I'd go ahead and stop here and put that over 1. Because what I would end up doing is I would just cross multiply. So when I cross multiply it, 1 plus e to the negative x equals 400. So now all of a sudden it's something that I can actually probably deal with just a little bit more. So if I were to go ahead and take my 350 here, a couple things I could do. I could distribute it in, or I could divide it out. I'm going to go and distribute it in so that way I don't have to deal with quite as many decimal or fractions here. So if I were to distribute it in, I'd have 350 plus 350 e to the negative x equals 400. Then if I subtract 350 from both sides, I'd get 350 e to the negative x equals 50. So we're kind of getting there a little bit. What if I divide both sides by 350 just for the fun of it? And if I were to do something like that, 50 over 350, that would be 1/7. So I'd have e to the negative x equals 1/7. Since my e is my base, I can change that to log base e of 1/7 equals negative x. Or log base e would be natural log of 1/7 equals x, negative x. And if I multiply both sides by -1, I get -1 natural log 1/7 equals x. So that would have been a great answer. Nothing wrong with that answer. X equals a negative natural log of 1/7. But if I wanted to, I could even make this even a little more cleaner. What if I were to take that -1 and since it's being multiplied by the log, what if I were to take it and make it an exponent? In other words, if I were to take that exponent and I were to make it an exponent for this whole fraction. So then if I were to choose to do something like that, I'd have natural log of 1/7 to the -1. And to get rid of that negative exponent, I just have to flip my natural log. So natural log would become 7/1 to the first power, which is the same thing as natural log of 7. So it turns out that this answer the same thing as that answer. I don't really care how you do it. You're just going to take your pick, whatever one you want to go with, knock yourself out. So, and again, that's one of the things that people struggle a little bit with exponents and logs is all the answers, they can be written in multiple ways. You just got to find the way that works best for you. All right, we're going to try one last problem here. And this one's just going to set us up for the second half when we get into it. What happens if we deal with something that looks just crazy? Sometimes we just deal with things that just don't look pretty. We try to look at it, we see if we can do something with it. We just can't do anything with it. Well, when that happens, we can do something called a U-substitution, which we've used other times during the course of the year. And we could choose to make something that doesn't look great to us in terms of something else. So for instance, what if I let u be equal to e to the x? That means every place I see an e to the x, I could change that to u. So then I'd have a u in place of each of these things. So I could take it from something that is just not sitting pretty with me to something that maybe I can actually do just a little bit easier. Turns out it's just a quadratic. That ugly thing looked like just a quadratic. Now I'm going to have to go and undo that U substitution later on, but let's go ahead and just solve this for you. So if I were to solve this for you, you can go ahead and factor it. Some of you guys are still using the box and diamonds, so good. Some of you guys are doing the FOIL method, that works too. You can solve it any way you want to. And we do a U zero product property. So U minus 4 equals 0. U plus 3 equals 0. So U equals 4. That's not a 4. And U equals -3. So we solve it for U, but remember, U was standing for something else. U was standing in the place of e to the x. So we're going to go back and we are going to plug our e to the x back in for U. So e to the x equals 4. E to the x equals a -3. So now I'm stuck in exponential form. So I'm going to make the base of my exponent be the base of my log. And I get natural log or log base e of 4 equals x. I get the log base e of -3 equals x. Well, friends, bells and whistles go off here. First up, can you ever take the natural log or a log of a negative number? The answer is no, it can't be done. So this one right here, this is no good. This is an extraneous solution. So this one doesn't work. However, this one, I'm taking the log of 4. That does work. So I end up with natural log of 4 equals x. That's a great answer. But notice, only one of these answers works. Sometimes that happens. Sometimes we end up with extraneous solutions. That's why it's so important to make sure we check our log. And we also, at the same time, we could have done it here. We could have noticed here that it's not going to work, that there'd be no solution because, friends, you can't, there's no exponent that can turn a positive value into a negative value. It just can't happen. So anyways, oh, it looks like I added a couple plus in there. I'm not really sure why I did that. I meant to do this. There we go. Anyways, friends, that gets us halfway through our solving logs and exponential equations problem. So go ahead and play with the homework a little bit, see what you can do, and then we'll come back and we'll take a look at the second half of that. All right, take care.